Hello and welcome to another SME Media webinar. I'm Amy Bryson, contributing lead editor of Smart Manufacturing Magazine. And today we will explore accelerating sustainable mobility, the road to 2032. And this presentation is sponsored by Drive Aluminum, which is reshaping mobility through its commitment to help automakers design the safest, strongest, and most carbon neutral vehicles. And we're lucky to be joined today by three speakers. And before I turn things over, I'd like to go over just a few quick housekeeping items for our attendees. If you look at the right-hand side of your screen, you'll see a question and answer box. And if at any time during today's presentation you'd like to ask our speakers a question, just type it into that Q&A box, and we'll get to as many questions as we can at the end of the presentation. If you experience any technical issues during the webinar, like a loss of sound, please also use that Q&A box to alert us, and we'll respond to you individually with a suggested fix. If you're not able to rejoin the live webinar or you have to jump off early, this presentation will be available in its recorded format after about 4 p.m. Eastern today. And you can watch the webinar as many times as you like. All you need to do is log in using the credentials you used to join us today. And we encourage you to share those credentials with any colleagues who might also benefit from this topic. Now it is my pleasure to turn things over to Mario Greco, who is a longtime contributor to the Aluminum Association's Aluminum Transportation Group and who serves as the Director, Global Automotive for Novelis. Welcome, Mario. Happy to have you join us today.
Thank you, Amy. And good afternoon, everyone. It's a real pleasure to be able to speak with everybody today. Before I get into it, I did want to set the stage a little bit for the Aluminum Association and the Aluminum Transportation Group, and then I'll hand it off to my industry colleagues and speakers who will walk through the bulk of the presentation. But so with that, I wanted to share a little bit about what is the Aluminum Association specifically and what is Drive Aluminum. Well, like many other associations, we're a consortium of upstream and downstream manufacturers in the aluminum industry. So that's both primary producers of aluminum as well as value-added semi-fabricated components downstream. And of course, we're comprised and we operate across several committees, and we work on both from the spectrum of policy and influencing as well as standards in our industry. As you can see, though, we have a significant contribution both in terms of the industry's employment, over 700,000 jobs supported by the aluminum industry, and really over $200 billion worth of economic output when you really measure it across all our members. And more importantly, and something that you'll hear about today from our speakers in terms of the roadmap, the industry's conscious of the needed growth and demand for aluminum in various end markets. And really, we've invested in lockstep to help support that growth, over $10 billion over the last 10 years, really geared to supporting a lot of the end users and end markets that are looking to gain efficiencies. So with that, who is the Aluminum Transportation Group? A small committee, but powerful, focused really on the automotive industry specifically. As you can see, we have both some direct full members as well as some additional advisory members. This is really dedicated to focusing on the auto industry and achieving the industry's objectives, whether gaining of efficiency or better product in their future strategy. We're going to hear a little bit about that through the course of the presentation, and really making sure that they achieve the highest value and use for the adoption or usage of aluminum in the various ways in which they want to integrate it in their future vehicle programs. So we have a varied membership, again, across both those primary as well as secondary, if you will, downstream producers. So really being able to bring the best in knowledge transfer and knowledge for the auto industry to achieve its own objectives. So let me talk a little bit about what we have done and give you some examples of what the ATG has been focused on in the past in support of that auto industry. if we take a quick look back over the last several sort of administrations, or really the last decade and a half, one of the things that, of course, has been the focus of the auto industry is the fuel economy regulations. And back in the 2004 through 12 time period, it was really important to make sure that we supported the industry in taking full advantage of technologies that would help them develop those more efficient vehicles in support of the fuel economy regulation. And what's one such element was taking the full advantage of mass reduction across the vehicle fleet, particularly in North America, where there was a predominant and still is certain heavier, larger vehicles in the fleet in comparison to Europe or other regions. So we were instrumental in working with the industry and the policymakers in shifting from the draft proposal, which was a weight-based regulation, moving it to a more holistic footprint-based that really allowed OEMs in North America to choose the adequate amount of technology and aluminum mass reduction necessary across their entire vehicle portfolio, whether small or large cars, and didn't force them to really develop or constrain their portfolio of vehicles that they put into the market, thereby constraining consumers' choice, if you will, for those vehicles. And that really led the way for some of the first aluminum intensive vehicles. Of course, I think a lot of the participants here, and you'll hear about the aluminum F-150 that somewhat started it all, but it really showcased how very strategic OEMs were able to select the technology that they wanted, in this case, aluminum mass reduction, to achieve some of those objectives. And this vehicle is a textbook case of that. As we moved further along in that arena in the 2016, 2012 time period, it was really important to look at how these regulations needed to be reviewed and assessed, how well OEMs were doing and how well the regulations were contributing to consumers' choice and consumers' efficiency, a really important element clearly for the OEMs themselves. And we really helped to shape the narrative around the technical assessment review about the levels of mass efficiency that could be utilized by using very specific research-based data and policy, and giving that to the policymakers to understand how well the technology was being developed and basically adopted within that space and how far they could go. And lastly, if we think about sort of almost going into the modern period, of course, fuel economy regulations are still an element, but we move more and more towards electrification. But really, this was engaging with the industry on maintaining how the safety and the efficiency of these vehicles was going to be deliver the objectives of both the policymakers and, again, the consumers in terms of their choice that they had. So really, some snapshot of how the ATG and specifically helped shape and support the auto industry towards their goals. And hopefully that will lay a little bit of groundwork as you hear from our speakers into the future of our roadmap. But I wanted to finish off before I introduce them both with what's the focus today, right? We recognize that the auto industry is moving towards electrification, again, in part due to those fuel economy regulations. And for us, it's important to understand how do we help them to make those EVs and make their fleet more affordable, accessible to consumers that are more and more interested and looking to move to that kind of product. And things like the offset of weight in the vehicle for a smaller battery pack, which improves the overall affordability, and making sure that OEMs have that knowledge and have that sort of data-driven information to help understand what is the net benefit of mass reduction as a comprehensive part of their development. Of course, sustainability today more and more on the minds and certainly on the strategies of every OEM as well as for us. And so how do we support the industry today with full life cycle analysis studies, and more importantly, the approach and methodologies that will give them the ability to really compare adequately the choices that they want to make, that they need to make for a more sustainable portfolio of vehicles down the road. And lastly, none of this would be, really effective if we didn't have a channel to be able to share that information and knowledge with all of our essentially customers across this industry. And again, those OEMs in terms of things like a technology forum that we host, knowledge sharing and participation in terms of both requirements or specifications that we can provide them to make sure that they're maximizing the benefit of their chosen approach for mass reduction in their vehicles. So hopefully I laid a little bit of groundwork on the ATG, Aluminum Transportation Group, within the Aluminum Association. And what I would like to do now, it gives me really the honor to present our really speakers for today, who will guide you through the development of our roadmap, and subsequently we'll answer some questions. So first up, I will hand it over to Helen Wykamp, and I'd like to introduce Helen is a principal research scientist at Hydro Aluminum Metals. Helen is been involved in recycling friendly alloys in the automotive, EV, structural and crash management components. Helen has over 30 years in the aluminum industry, focusing on alloy and extrusion process development. She is an active member of the association, of course, and deeply involved in the technical committee of the transportation group. Prior to her time at Hydro Metals, Helen worked for a variety of suppliers, including Hydro Automotive Structures, Benchler, and Shape Corporation. Again, with focus on alloys and extrusion processes, particularly for crash management systems. And finally, Helen has a bachelor's degree in metallurgical engineering from Michigan Technological University and a master's degree in material science and engineering from the University of Washington. Secondly, after Helen's presentation, I'd like to introduce Raj Dasu. Raj is the R&D engineering director for Commonwealth Rolled Products. With over 25 years of industry expertise, he previously excelled as a senior project leader at Gestamp and Sodesia, and engineering manager at Introtech Inc. In his role, he's led R&D efforts at Commonwealth Rolled Products for nearly a decade at this point. He's an active member as well of the technical committee of the transportation group. And Raj holds a master's degree in mechanical engineering from Tennessee Technological University and an MBA from Michigan State University. So with that, I lead you and give you to Helen for the rest of the presentation.
Thank you, Mario. Before talking about the content of the aluminum roadmap, I do want to spend a few minutes just talking about the process as to how we developed the roadmap. So in early 2021, the ATG held a 2-day workshop with over 120 participants from the automotive and the aluminum industry. And the purpose of that meeting was to understand future challenges within our industry and discuss ideas for the roadmap for automotive aluminum. Throughout the year, we held many workshops with the key stakeholders, and then the roadmap was eventually finalized in December of 2021. The roadmap identifies 5 pathways, which I'll describe here in just a moment. But it also identified pathway goals together with future opportunities, technology challenges, and potential research activity. The ATG, the Automotive Transport Group, we use this roadmap to develop data, conduct research, and provide educational tools toward the automotive industry. But we do recognize that it's a very dynamic industry, and so that priorities can change at any time. So we're always looking for feedback from the OEMs so that we make sure that their needs are being addressed. So how do you provide feedback? Well, first, you can download the roadmap using the QR code that you see on your screen, or you can go directly to the Drive Aluminum website. And then once you review it, you can then provide questions or comments or feedback directly to the ATG by the email that we have listed, or contact John Newman at the Aluminum Association. So with that, I'm going to now describe the 5 pathways that were developed, and I'll also describe the main and key objectives for these 5 pathways. So the future vehicles pathway, the main objective is to reduce overall cost and create alloys for EV batteries. For the next generation fabrication, the objectives are to enable real-time data collection at all manufacturing steps, pursue innovations to improve formability, and develop innovative next-generation fabrication processes. And then for recycling and sustainability pathway, the objectives are to develop high-speed, high-volume sorting and recycling, enable and ensure life cycle management across the value chain, and identify ways to recycle bonded and riveted joints. So those 3 pathways we just touched upon, and they'll be reviewed in future webinars at some point, or you can review them through the roadmap itself. But today, Raj and I are going to be talking about the 2 final pathways. Raj is going to be describing design engineering, and then I'm going to be talking about the new alloy products and grades pathways. So when we started, for each of the pathways, we first identify objective. And for all of the pathways, the key objective is keeping in mind that collaboration between the OEMs and the aluminum manufacturer is key. So we have that as the core for all of our objectives. But then for the new alloy objectives, or the new alloy pathway, cost is one of our key objectives. We know that OEMs are looking for higher strength, better formability, higher ductility, higher fracture toughness, but they want that all at a lower cost. So that's one of our key objectives. Secondly, we need to increase the use of simulation tools like AI to help reduce alloy development times. And then finally, we need to identify and standardize property testing and reporting so that the OEMs are able to compare results among multiple suppliers. Then, after we've identified the objectives, we then move on to goals. So we've divided goals into near-term, mid-term, and long-term goals. But again, this is a living document, so we know that the goals can change where they are, either mid-term, long-term, at any time. But for near-term goals, near-term goals, we're looking at non-heat treatable castings. We're looking at tighter, more consistent properties and increased performance, and then higher strength extrusion alloys that can more easily be extruded so we can continue to compete with our steel counterparts. For our midterm goals, we're looking at standardized formability tests for new alloys. We're looking at high ductility casting alloys and structural die casting alloys that eliminate the need for heat treatment. And then we're looking for alloys for large castings that would allow us for part consolidation with an aim at shorter cycle times and low-cost casting processes. And then finally, for long-term goals, we're looking at new alloys that meet or exceed select properties of high-strength steel. One example would be improved formability. And then we're looking to continue to develop recycling compatible alloys or alloy blends that would improve vehicle end-of-life recycling. So then once we have objectives and goals that have been developed, we can develop then action plans so that we can start collaborating and making progress on the roadmap. So for high-performing alloys, we're looking to develop affordable, high-strength, corrosion-resistant grades that exceed the specific strength of press-hardened steels. Next, we're looking to understand the complexity of the strength-formability interaction to improve overall performance, and then ensure all new alloys are fully compatible with closed-loop and end-of-life recycling. Action 2 is to increase the use of simulation, and that includes updating material cards for CAE engineers so that can help speed up the development time and reduce costs. Expand the use of simulation tools to reduce alloy development time, and then develop databases with accurate data for each alloy. And then finally, testing and qualification methods are not standardized or consistent across aluminum producers or OEMs. So standardization of testing and qualification would help us reduce overall development time. So we're looking to achieve industry-wide consensus on material specs and testing, ensure consistent test data across multiple testing sites, and then develop standard component level testing that will improve upon the usual coupon level type of test. Next, Raj will describe the design engineering pathway.
All right, thank you, Helen. Now I will go over design engineering objectives, goals, and action plans. So design is an iterative design decision-making process supported by fundamentals, sciences, process design tools, computational models, and a wide spectrum of physical and chemical properties of the material. OEMs make material and manufacturing process selections driven by styling, packaging space, structural performance, manufacturability, serviceability, mass, and cost considerations. Our objective as ATG are one, build awareness of aluminum capabilities, provide design data that can help bring products faster to market with lower mass and as economically as possible. To understand and resolve key design challenges, aluminum offers, versatile product portfolio. You have flat roll products, you have extrusions, you have castings to resolve the most intricate challenges in the most efficient ways. So, and then finally, create future products, understanding industry challenges, whether it is manufacturability, for strength or joining, or corrosion or sustainability, cost, things that Helen talked about, allows us to continue our research efforts to deliver next generation products that continue to deliver your needs. This is all only possible with close collaboration between OEMs, tiers, and aluminum producers and users like you. Next, I'm going to talk about the design engineering goals. So ATG goals for design engineering are classified into near, mid, and long term. Please note that these priorities are developed based on feedback received through voice of customer interviews. These priorities could shift and are be adjusted as we collaborate with OEMs and a robust feedback loop is achieved. Really close collaboration between OEMs and aluminum manufacturers is needed to accelerate the development process. As stated earlier, collaboration allows us to understand what the key challenges are and enables aluminum producers to develop next generation products to overcome and produce state-of-the-art solutions. So let me talk a little bit about near term. First, we are looking at improved performance in all key material specs, whether it is formability, aging, hemming, joining, styling, paint appearance, etc. Next, we are looking at developing a catalog of case studies in collaboration with OEMs and tiers. So challenges and solutions to overcome are more open to the industry that can enable pushing the frontiers of research and then applications. And then finally, in the near term, understand and develop more recyclable alloys, develop higher scrap returns, enable end-of-life recycling are the key objectives there. Jumping to the next midterm, here first we are trying to tackle improved material models. Automotive industry is headed towards simulation-driven product development. We understand our part in ensuring accurate material models, allows reduced time to market, and this is a focus area for us. Next, we're going to focus on the next generation door / closure designs with uni-alloy outer and inner and reinforcements which will enable better end-of-life recycling. A closure can be, taken apart and be recycled directly into making the next automotive coil. So, and then finally, develop robust high-strength solutions in all product forms, like I said, in roll products or in extrusions or in castings, um, to compete on specific strength with other materials. And then long term, our first goal is to harmonize OEM specs and design requirements in order to reduce complexity, improve resiliency in supply chains. Obviously, this requires the greatest collaboration between OEMs and aluminum producers. And that's why this is in the long term. Hopefully, the relationships with OEMs and between OEMs with all the sustainability goals are mature enough that we can bring this spec harmonization into realization. Next, continue to support right material in the right place with improvements in multi-material manufacturing compatibility, and overcome some of the challenges that exist today. And then finally, to take the aluminum application to the next stage, aluminum alloy blank developments to improve part consolidation and reduce manufacturing complexity, and then hence the cost. So that's a summary of goals. Next, let me talk a little bit about action plans. So objectives and goals are then developed into action plans that we can start collaborating and making progress. They're organized into three main areas. Design data. Here, our first focus is, we understand the importance of having accurate material models, whether it is predicting formability or product performance. So we plan to develop an open source material database from all major aluminum producers, so manufacturers can have that access, can make those material choices more efficiently and in direct comparison with each other, not only from different producers, but also between different product forms. Next, provide guides on what key properties tied to the end product, either manufacturability or performance, whether it is yield strength or N value driving formability, or strength for crashworthiness. Next, we talked about specification integration between OEMs. This is a win-win. It reduces the complexity for aluminum producers, improves supplier resiliency and sustainability efforts of industry as a whole, and it helps OEMs from having supply chain resiliency. As ATG, we recognize opportunity to develop improved material models, to bring products to market faster. For example, kinematic hardening models to improve springback or and compensation predictions. Gizmo models to improve crashworthiness accuracy. The key focus here is to avoid late changes in release cycle and bring products faster to the market at the most efficient cost. Under joining and bonding action plans, as we progress from closures to body in white structures, enabling versatile joining methods with one-sided or two-sided axes or multi-stack ups, joining different aluminum product forms, and finally mixed material joining becomes essential enabler. Plan is to benchmark existing technologies and drive innovation to further the aluminum applications. Next, optimizing aluminum joining, whether it is optimizing flange lengths to take mass out, or define a balance between adhesive and other forms of joining to improve cost, manufacturability, performance, and recyclability. Under So next, under plant component design, this is an ambitious goal. Plan here is to define a vision for an all aluminum vehicle plant where different aluminum product forms are optimized along with the manufacturing methods and can be brought together in the most economic and sustainable manner. They can help drive the scrap reductions in manufacturing, as well as end of life recyclability, and ultimately lower manufacturing and vehicle costs. So let me talk a little bit about projects we have as ATG in action. As we moved into action on the objectives, goals, and action plans, we realized it is better to organize the teams into product forms to improve goal congruence and delivery. So we organized the roadmaps into 4 product teams and the projects as well. The first one is castings, flat roll products, extrusions, and then sustainability and recycling. Sustainability and recycling underpins, all product forms and connect the teams to the overall roadmap. So let me touch on what ATG delivered so far. Here is an example of flat roll product research delivered through a webinar by Laurent Sheffy with the objective to provide, again, practical information to help OEMs and tier ones engineers deploy aluminum. You can scan the QR code or visit drivealuminum.org to access and watch the webinar if you prefer. Here is something we are actively pursuing or working on. Flat roll product working group under ATG is undertaking to develop a guide to optimize blank leveler settings. All flat roll products has to go through leveling process and blanking process before they go through the stamping. Over leveling of material during that blanking process can compromise material formability performance at the OEMs or tiers. So ensuring correct leveler settings are applied based on incoming material gauge or grade and shape ensures robustness and OEM stamping operations. As at ATG, we recognize the need and focused on delivering best practice guide to improve in-field performance for the flat roll product suppliers as well as the OEMs using the products. So we kicked off the study and is in the process of collecting data. We intend to make the best practice guide widely available through drivealuminum.org. So in summary, I hope I gave you a flavor of what ATG has already delivered and what we are working on. Please provide input and on how we are doing and if we need to shift, adjust our priorities based on what your immediate and future needs are, and help us push the boundaries of aluminum implementation into automotive. With that, I'll hand it off to Mario to conclude today's presentation. Thank you.
Thank you, Raj. Yeah, no, some good elements there. What we wanted to just conclude on is, just stepping back here a second. So the roadmap was clearly a document that Helen mentioned as well, is a composite of really the feedback and the focus areas, and it's a living document as such. So we recognize that the changes in the auto industry are quite dynamic, and so this is a document that will be continually updated and really bringing some of the newer information regarding things like large castings that are being adopted. I see a few questions in our Q&A as well around that topic area. We know that that's not just a trend effectively anymore, but an area of focus and intense development for the auto industry. So wanted to just make the call out that the insights, your insights on this kind of research in those areas are really important to then put our focus and our resources in the right place and make sure that we can bring that in support of the objectives that you all have. So obviously a way to do that is once again with the scanning of the QR codes here, or being able to go directly into the documents, or reaching out certainly to our technical committee leadership, John Newman, or any one of us certainly as part of this webinar. So with that, I think I'll conclude and then open it up to a few questions. We wanted to just remind for the next session, which really is going to dive into the sustainability topic, which is clearly an important area for both the industry and the manufacturers. So on November 7th at 2 p.m., there'll be a presentation really talking through some of the elements around the sustainability aspects of aluminum in this industry. So mark your calendars if you're interested, or if that is part of your topic area. Please join us for the next session. So with that, I think I'll invite Amy or team. I do see some questions that have come in, but perhaps we can lead off with some questions. Raj, maybe I'll ask you, just teeing off from the living document topic that we just shared, I would ask, the roadmap really was done in 2021. A few of, Helen shared kind of that, how it was born, if you will, but a lot has happened, right? And so what are the plans to revise the roadmap periodically? How else do you keep it current? What is kind of the process there beyond the feedback?
Yeah, thank you, Mario. That's a great question. The roadmap was created to be a living document. I think we talked about it during the presentation a number of times. Definitely, we are always evaluating opportunities to refresh and update objectives, priorities, and action plans. The association recently released a decarbonization roadmap for aluminum industry as a whole, which is a reasonable update to incorporate again into the ATG roadmap. And definitely we are always aware that there could be changes in the regulatory landscape if there are significant shifts or drastic shifts. That's another opportunity to refine and update and really focus on what our customers are looking for. So we also hope to use discussions like these webinars to get input and feedback. Hope that answers.
Yeah, very good. So maybe as a almost follow-up to that, Helen, I'll turn to you. There's a question around, how are the automakers reacting to this roadmap? Raj talked a lot about the actions, but perhaps there's, what are the automakers doing? How are they reacting to it? Maybe something you can help answer.
Well, in short, I think the reaction has been positive. But I will say, as we've said several times, we did involve the OEMs early on to develop the roadmap. So we included 120 stakeholders, the OEMs, aluminum manufacturers. So I think we initially got some good information, but as everyone has said, we need to keep this a living document and keep the input coming so that we can continue to, keep the ideas and the needs of the OEMs fresh and that we're working on the right things.
Excellent. So, just looking through the Q&A and we talked very briefly about it, but I mentioned it. But Raj, maybe this is something that you can help. There's several questions around the topic of gigacasting, megacasting. In particular, starting off with basically, has the growth around this trend, these large castings, spurred any innovations, particular innovations in aluminum sheet solutions, maybe to accommodate these larger components in the vehicle, combining multiple parts, something like that?
Yeah, that's an interesting question. Yes, I touched on it during my presentation. Talked a little bit about the aluminum welder blanks. That's again trying to do part consolidation in the sheet form. We're also working on, how do we enable, putting components together from various aluminum product forms, whether it is sheet to a extrusion or a sheet to a casting. So we're continuously looking to improve that value proposition and making the change improvements so we can make progress there. Great question.
Very good. Yeah, and I know there's a lot of interest in this space. Obviously, I can see other questions in terms of, whether this seems to be a significant growth path for aluminum or if it's still too far in the future. And I think certainly, Raj, as you mentioned, we've seen this now to be something that a number of OEMs are, either already developing in terms of near future vehicles or certainly consider strongly for the future. So certainly a growth for a certain area of aluminum specifically. Maybe, Helen, I'll come to you a little bit with this one. There's some questions around this EV transition, or maybe Raj, you can jump in as well. Do we have any data regarding aluminum content between internal combustion cars and in comparison to EVs? And I think there might be some references we can help.
Yeah, I think the Decker report, the most recent Decker report, will definitely give you some insight as to the increase of aluminum in both ICE and EV. But we definitely see a growth of aluminum over the next 10 years, just mainly due to lightweighting, the needs for lightweighting and improved performance. So yes, I think there is data out there that, like I said, the Decker report could definitely give some insight.
Excellent. Yeah, and we can, I'm sure the links are there on the presentation, but they'll be shared also with everybody, I presume at the end of the webinar, to go to the website and they can download that.
Yeah, and regardless of the speed of transition to EV, aluminum is providing solutions in various product forms, that can service whether it is ICE vehicle or it's a EV or if it's a hybrid in the transition time. So I think whether it is providing longer range and smaller battery pack for EVs, or higher fuel economy requirements for ICE, or both for the hybrids, I think that's where aluminum really shines.
Fantastic. Maybe one last, I think, really good question as well, and something that you had touched upon, Raj, as part of the design and engineering roadmap. But there's some questions around, CAE and sort of how the automotive teams can find, reliable, robust material cards on aluminum products, and how they should maybe, what's the most effective way for them to gain that information, right?
Yeah, as ATG, we definitely recognize that there is lack of a coherent database that, definitely OEMs or tiers can tap into. Today, if you were to find this information, you reach out to individual aluminum producers and gather data and develop your own database internally and then rely on those. ATG is definitely recognize that challenge, and I think I talked about a little bit in the midterm to a long term is to develop that database that is more central and available information from all aluminum producers. Also, part of that is to harmonize the testing method. So, the data from one aluminum producer can be directly compared to other aluminum producer without the question of, whether the test method is slightly different or if the data has some differences because of the way it was post-processed, as we are going into simulation-driven product development, garbage in, garbage out, right? So you definitely want to make sure all the inputs are accurate and can drive that bringing products to market faster. So this is where I think we'll definitely make a progress in the coming years, and it's one of the key focus area for ATG.
Very good. One other area here with the questions, of course, of particular importance, and obviously we've shared that in our next webinar, we are going to be focusing and sort of deep diving on the sustainability question, but perhaps there's a few questions here, and Helen or Raj, I'll tee it up for you guys, but how's the aluminum industry helping automakers kind of on their path towards decarbonization? Areas that participants are asking are areas around CO2 impact on the primary, or of course the recycling element. So
I'll start off.
Go ahead.
Yep.
Go ahead, Raj.
Good. So I'll start off. I think today definitely most aluminum producers are trying to take, manufacturing, or whether the stamping plant scrap or blanking scrap back to produce, the next coil. So the scrap is fully in a closed loop. That's the primary focus at the moment. Obviously, as we progress through, synchronization, we're also looking at alloys that can be developed that can use scrap from different product forms, whether it is casting or if it's extrusion or sheet, and then be able to produce, various product forms from it without compromising on some of the key characteristics. And obviously, the more recycling content we use, the less, carbon footprint we create in using primary aluminum, which is the biggest energy driver. So again, focus there is to increase that recycling content.
Yeah, and I agree with Raj. I mean, that's even one of our targets for the ATG is to develop these recycle-friendly alloys and get those on vehicles. But most aluminum companies are trying to find ways to increase the post-consumer scrap as well. How can we do that? How can we, delacquer? All these aspects that we need to consider when we're digging deeper into the scrap stream.
Yeah, very good. And maybe just one reference for participants, if they hadn't seen it. So recently, the association itself did publish a North American decarbonization roadmap. So some of these exact details or answers that Raj and Helen were sharing, you could find that in a more detailed sort of way laid out in what the industry is doing along these pathways to support that decarbonization, and then obviously elements that pertain to those kind of areas. So I know it's clearly and certainly for design and engineering an area of high interest, but I'll come back to it a second because I see a couple of questions. But Raj, on the design application front for these large castings, is the aluminum industry seeing, proliferation across different areas of the vehicle, or are they, more and more focused on the underbody of the vehicle for now?
Obviously, Tesla is the leader there. I mean, they have used giga castings that incorporate front end structure, back end structure, and almost create a Lego style car putting together with less manufacturing footprint, right? So yeah, that's definitely evolving. I mean, the availability of those giga castings, and I mean, there are some challenges on serviceability. How do we overcome some of those? Those are being worked on. Definitely, there are trends towards more and more part I mean, the overarching theme is part consolidation and reducing manufacturing footprint. And we recognize that, and we're trying to enable in all product forms solutions that can aid in that.
Right. Yeah, absolutely. And maybe lastly, I know there's here, I think we've kind of reaching towards the bottom of the hour, but we've answered a few of the questions. Helen, you touched upon it, I believe, before, or Raj, you did, but there's other questions, you know, in the focus of the current roadmap. BEVs we've spoken to have been part of that. But in that journey towards, you know, just more sustainable transportation, obviously hybrids play a role as well. You know, is there plans to sort of incorporate that, any areas of hybridization that would drive research focal areas into the roadmap?
That's probably more of a Raj question, but I mean, from an alloy standpoint, anything that we can do toward lightweighting, you know, I think we're trying to do it. It's in the forefront and keeping cost in perspective. But from a design standpoint, I don't know, Raj. Do you have any comments on that?
Focus there is to deliver, you know, higher specific strength alloys, you know, higher strength with, I mean, obviously the low density of aluminum, so we can penetrate into body in white applications more and more, and allow that, you know, not just the primary mass reduction, but the secondary mass reduction opportunities that come with it, and then again increase that. Whether it is hybrids, I mean, it's, you know, increased fuel economy. They all already have, you know, increased fuel economy compared to the normal ICE engines. But you know, how do we extend that even further and make that hybrids sweeter?
Yeah, sure. And Raj, I'll keep you a second on the hot seat here. You spoke obviously about the focal point in terms of our standards and certain requirements and stuff. Can you speak or elaborate a little bit more on what the sort of standardization approach might look like, or what we're, you know, doing to help facilitate really the convenience and the robustness for OEMs in terms of standardization compared to maybe what is there today?
Yeah, standardization, I can take it in two forms. One is standardization of material data. So, you know, the data is more consistent between aluminum, one supplier to the other, or one product form to the other product form. So the OEMs are not constantly have to make judgment calls and, you know, able to plug in different inputs from different producers, so they can seamlessly do that. That's the goal there. From standardization of the specifications itself, I think I talked a little bit about it. It's a win-win situation, to be honest. I mean, so right now we have some OEMs use certain specs, and you know, other OEMs use slightly different specs. That creates, you know, kind of, you know, certain suppliers can only supply these products and not the others. And then um, to dive into that, it actually goes into sustainability within the aluminum producers as well. So the more number of different alloy variants that we are producing with the different chemistries, the more we are polluting our scrap streams within our four walls, and that actually compromises the sustainability aspect of it. So I think in the long run, I think that's where we're hoping the OEMs will come together in the interest of sustainability for the planet, and also their individual goals, you know, in harmonizing the specifications. So, you know, scrap from one OEM can go into a different aluminum producer than who the original supplier was, so it doesn't have to travel, you know, longer distance. So we're trying to reduce the footprint on scrap return streams, if you will. So that's the holy grail. I mean, obviously that takes a lot more collaboration, and we understand that. And this is where we are hoping that the industry comes together and work together to harmonize. This is not something unusual. When steel started, they had specs that are very individualized for each steel producer, and eventually there were spec harmonization. So it's not something that cannot be achieved. I think it's definitely takes commitment and collaboration, greater collaboration.
Very good. So I'm conscious of we've reached kind of the end of the session here. So I'll maybe pass it back to Amy for concluding or.
Absolutely. Well, I certainly want to thank Mario, Helen, and Raj for sharing your insights with our attendees today. And I want to thank our attendees for joining us. We hope that you found the content beneficial, and we hope that you'll join us again soon. Until then, make sure that you stay up to date on all things smart and advanced manufacturing. You can find links to additional webinars, podcasts, publications, and news by visiting us at advancedmanufacturing.org. Take care, everybody.